Okay, I lied to you about the going to the drill press next to drill a hole in the base of the stem at the end of the previous segment. At that time, I thought that I would just refer back to a previous video from a different series concerning the usage of chucking reamers and mortise squaring. But then the more I thought about it, the less I liked the idea of having to jump between sets of segments of these repair videos and have to chase around after them when I should just put them contiguous into each one whenever they recurred. Makes life a lot easier for you guys. So before we go drilling any holes, by the way, I got the base of this squared off, and we have a surprise. Well, it's not a surprise to me, but it is to most people, that we'll talk about when we get to the drilling operation. Anyway, the thinner the shank, the more likely what I'm about to say will be true, which is that the pressure necessary to hold a stem in a shank on any pipe will, over time, push the wood outward and make it trumpet shape. It'll flare it, and it can happen only internally in some cases if it's a big fat shank. If it's a fairly thin one like this, it can actually trumpet the outside as well. Now, I don't know that you can see it, probably not, but that actually is slightly trumpet shaped. Now, whether the owner of the pipe will object enough that he'll want that to be recut and refinished, I don't know. I doubt it. He's a purist kind of. He'll want the original finish on the entire pipe, so I'm not about to do that without a request. But the inside is not an option. And here's what I'm talking about. The base of the mortise is 0.267 inches in diameter. The end of the mortise is 0.275, meaning if you cut a tenon that is parallel sided, if it is the same, if it's 0.275 and you try to push it in there, you'll break the shank. If it's 0.267 and you put it in there and it's going to wag like the tail on a dog, it's going to rattle around in there. So no can do. We have to cut this back to shape using a succession. And here's what I mean. We're going to take this guy and, using special tools, we're going to remove the dotted area here. We're going to enlarge the base of this conical shape. Also, just to for completeness here, the outside is 0.487 inches, and then just a small distance, maybe 3/16 of an inch in, it's 0.483. I guarantee it wasn't cut that way. There's always a steady taper on these old classics. So, all right. Now, a chucking reamer is an odd piece of gear. It's a bit like a drill bit with a barbershop pole on it. Flutes. These are razor sharp, and they're parallel sided, and they're strictly for truing holes. And how you do it is you measure this using a pin gauge. There we go, pin gauge. They're like, a pin gauge is just a little piece of metal about that long, and they are 1/1000th of an inch apart. You get a whole set of them. I'd show them to you, but the set weighs like 50 pounds, and I can't want to dick with it here on this work surface. It's just a series of these guys, and you keep on putting them in there until you get to the bottom, and that's this measurement. And then you keep going up in size until one that just barely fits here, and that's your large measurement. So 0.267 to 275, and then you get into your reamers, and the nearest sizes are H, I, and J. 266, 272, 277. So we'll cut using those three. Now this is about the same size as it seems to be at the base, but it'll round it because it's probably a little egg-shaped as well. So we're going to go 1/1000th down. But anyhow, They're easy to use in principle, a little tricky to do reliably if you're not watching what you're doing. Okay, I just use a small 3/8 inch drill chuck, a replacement chuck. You can buy them on a hardware store for about 10 or 12 bucks. They make a great handle. Tighten them up with a key just like an electric drill. And insert that just like it's a stem in your pipe and rotate the work, meaning constantly. You don't keep this in one position and start like cranking on it because you're going to get crooked. You want to give it a short turn and then turn the pipe 90 degrees and then do it again. And so you're going to average out any imprecision in your direction this way. And as soon as it frees up, it'll suddenly kind of get loose and you're at the bottom of the hole. And so here we go. Now it looks like that's just smoking scuzz, but it's not. That's actually what briar looks like when it's been smoked for a long time. It's kind of like charcoal in there. But we got something out of it. So, here's the key. We just swap to the next one. And repeat the process exactly the same way. And once again, more wood. Now one left to go. It's a 5/1000ths jump, which is about as big as these guys get. For some reason, they're not exactly equal increments on these machinist letters. I'm not sure why that is, but there you go. Okay, and get a lot of trash out of this one because we cut the entire length of the mortise. Little snuff, anyone? Okay, now you can't see any difference from the outside, of course. We only dealt in thousandths of an inch, but that mortise is now as tubular as technology can make it. It's as good as the day it was made. So we're going to go over to the drill press now, for real, and drill this. And since it's going to be a pain for me to lean sideways into the camera at the drill press, I'll point something out to you now that is surprising to most people because they think any rotational tooling is by nature going to be centered. But if you look very carefully at this, I'm hoping you can see it, the hole is not in the center of where the tenon was. I'm not sure you can see it, but you'll have to trust me. Maybe I can highlight it with this a little bit. And it's important that you realize that or understand it, because if you were to try to chuck this in a lathe in order to drill that hole, now there are people who can do that, but it takes a 4-jaw chuck, a dial indicator, and lots of experience to do it quickly. It's quite a pain to do if that's not your job, if you're not really familiar with the process. Getting this thing so that the outer ring, the part of the old tenon, is dead center, and ignore the centeredness of the exterior as well as the hole in there, that's a problem with a lathe. it's absolutely effortless with a drill press that has got an XY table on it. So I get asked all the time why I rely on a drill press so much, and the short answer is for repair work, it's the superior machine. For pipe making, it can be done. You can make pipes with one, but then it becomes the stepchild. It's not nearly as useful for making pipes as it is for repairing them. Also, having put that white material on here, I can see this crack that radiated to the outside. So we are going to drill this, hope that the walls of this don't chip out because of that crack. I don't think they will. And then when we glue the new tenon in, it should hold the whole thing together for another 50 years. So, alrighty then. That's it at this station. See you at the drill press.